Okay, thanks very much. Good afternoon, ladies and gentlemen. Thanks for attending this presentation. I know it's lunchtime, getting close. I'll try to be as fast as I can. It's going to take me probably 20 to 25 minutes. My name is Tarek Amara. I work for Twitch. And today, I'll be talking about best practices for streaming high-bitrate video. Let's make this a bit interactive. You're free to ask questions when you want. And my joke will be, even if you disagree with anything I say, stand up and say wrong. So that's kind of an icebreaker for me. Today, I'll be talking about high-bitrate video. And high-bitrate video, people call it Ultra HD today. It is bigger pictures with high frame rate, high dynamic range, VR 360, which is represented as a 4K picture. I'll talk a little bit about the media flow, media delivery flow. I'll be talking about ingest, transcoding, delivery, and playback. And at the end, I'll talk about best practices or more than of advices for people to keep in mind before they design their Ultra HD workflow. My first slide is going to be about the Ultra HD video, high frame rate and high dynamic range. As most of you know, over the last 10, 15 years, probably a couple of decades, people used to capture everything in SD format. So it's 480i, 60 fields per second, represented on 8-bit data. And all of a sudden, we find ourselves today with a production being carried on Ultra HD, 60 frames per second. The ratio here is 1 to 60. And to be honest, the key to delivering a media is about the bitrate or about the compression in another sense. So if it is not for compression, if today we have the magic codec, which can do anything at 1 megabits per second, we won't be here. We won't be even talking. So it's about how compression progressed versus how data increased. The data increased by 60 times. Compression really moved from MPEG 2 days to H.264 days, which is a factor of 50% reduction. And then now we have a mature codecs, which is the VP9 and HEVC, additionally another 50%. And then there is the AV1, which is futuristic and probably trying to achieve another 50%. So where compression have moved by 25%, or maybe call it 400% compression efficiency, the media have increased by 60 times. And here we can ask the question, is it really worth it? And I know there are lots of skeptics. People say, OK, 4K TVs, I see nothing. You go to buy a TV at a store, really, and you watch it a little bit, and the guy tries to sell it to you, and it looks great. You take it home, you watch a couple of VOD or live streaming, say, rubbish, that's not good. And you're not enjoying the experience. So that's why 4K is great as long as it is delivered correctly. So if you try 4K and really smash it to have the biggest resolution, the high frame rate, you don't encode it efficiently, you don't deliver it efficiently, you're ruining the experience. And video quality is key on lots of markets. There are markets where quality doesn't really matter, but there are markets where people try to enjoy the experience, especially with the new technology. Also, the high frame rate is something that is brought a lot, and there is lots of argument. People think, oh, we don't need really high frame rate. I cannot see the difference. There are markets where high frame rate is important, like for us at Twitch. It's something specific for us where we deliver a lot of our content that we deliver is gaming content. And that gaming content is going to be watched by gamers. People who are familiar with watching the games, they know how it looks like, and they play it at 60 frames per second themselves. And they expect high quality because they're familiar with watching content, which is high quality and compressed. And to give you just a brief, my connection doesn't work, so I'm going to do this. Where is it? So this is available online. It's a small application which tries to make people understand or have an appreciation of how high frame rate works. I'm going to start with everything static. There are 3 objects on that picture. There is the background, and there is the 2 balls. Oh, OK. How to do this? You can see that now. OK, there are 3 objects. There are the 2 balls, and there is a background. And for now, everything is static. So whether it is 25, 30, 50 frames per second doesn't really matter. So I'm going to try to move a little bit my 2 objects. The first one is 60 frames per second. The second one is I'm going to start with a lower than that. And I'm going to start moving it at 100 pixels per second. And as you can see, the bottom one looks horrible, stuttery. That doesn't even help the compression go well. And that's going to cost bits and give a ruining experience. You might say, oh, who broadcasts at 5 frames per second? Let's increase at 30 frames per second, which is what lots of people do. It's getting better, but you can still see the difference. Now imagine we move a little bit the background, and let's see what happens. Lots of people feel that the bottom ball is really very uncomfortable, is stuttery, and that adds cost to the compression itself. Now if I go even faster, you probably realize for the top ball, you can see all the black boxes, the white boxes. For the bottom one, it's really very stuttery. And all this without even the motion blur that the camera could cause. This is just an example so that people would appreciate how important it is to have a high frame rate and keep it when you deliver your content. This application is available online. The link is in my slides, but I can share it if someone is interested. So back to the slides. In addition to the high frame rate, which creates a smoother experience, there is a high dynamic range, which people believe is going to be the biggest seller for 4K content, as it really emphasizes darker regions, whiter regions, gives a completely different experience. Even in reality, you won't be able to see all that. It really improves the whole experience. Last point for the new, what we call high bitrate video, is the VRO 360, which is only deliverable because we can deliver 4K or bigger than 4K resolution. As some people might know here, how 360 is created by multiple cameras, and we stitch them all together, and we try to create a 4K or bigger than 4K picture. That's how we compress it in the traditional manner and send it to the receiving side. This is kind of a single slide, but just to give people appreciation, Ultra HD is great. It looks great as long as we make sure it can be delivered correctly to the receiving side. And that's where I start talking about these different points of the delivery platform. Here I'm going to talk about the ingest part, which I will try really to make it global. I'm not going to only talk about how Twitch does it or how Twitch is thinking to do it, but in general, the ingest could be anything. It could be someone who's doing live TV in conjunction with a streaming, or someone who's just doing a simple streaming, or someone who's doing a mobile device or simple camera to any other platform. I'll be talking about encoding, distribution, decoding, and display. These are the main representations, the main blocks that happens for a streaming flow. In the ingest, I'm going to be talking more about the challenges that the Ultra HD brings to the market that people need to be aware before deciding to go for Ultra HD applications. I'm going to separate a little bit here the live streaming from the VOD, because live streaming has got more constraints, a lot more constraints. And I'm not going to go through all these points, but if you see it for yourself, the main things, sorry. Taking a breath. For VOD, there is lots of things which already exist today. So someone who's having his VOD platform for HD or smaller can fairly easily move to Ultra HD, but they need to be aware of bigger sizes. Let's say it's going to take longer to upload their content. For editing the content, there are softwares out there which don't scale the picture, and you can apply those changes and editing to your Ultra HD pictures. But for real time, it's really challenging in terms of you need to encode it. It must be real-time encoder, capable enough, fast enough. You need to have a lower latency, because latency, as we've been seeing on the previous presentation, is a big issue and a big matter for people to go really at a lower latency for the customers. There are applications where you need to synchronize your HD and your Ultra HD streams. Processing is, by processing, I mean probably decoding and encoding, which I'll talk about in a bit. Needs to be as well fast enough. For VOD, you might think you have all the time you want. It's not completely true, but at least you can run it, test it, you're not happy, run it again, and you keep running. You keep trying. You can take an offline encoder, which encodes at 2-3 frames per second, but in live, it must be 60 frames per second. You don't have the option to try and test and redo it again. Now for the transcoding part, this is where the big point, the big decision-making comes. In terms of codecs, we have 3, or maybe I'm going to say 4, because AV1 is almost coming out there. There is the H.264 codec, and there is the VP9 HEVC, which kind of competing to each other. Well, competing, one is free, one is slightly expensive. And then we have AV1, which is the Alliance for Open Media. These are the Amazon, Google, Netflix, and other players trying to build their own codec, open source, free of charge. And let's go through these and see if any of them is not really adequate for such application. H.264 is mature, is great. You can find free software running there. The licensing mechanism is great. but it's not going to achieve a low enough bitrate so that we can deliver from A to B, especially on the OTT and the public internet. VP9 HEVC, lots of studies recently talking about, yeah, they can achieve pretty much 50% compression ratio or compression savings compared to H.264. Some people say HEVC is slightly better, like the recent Netflix analysis and study. That needs to be really taken with a pinch of salt because they haven't really compared HEVC as a spec to VP9 as a spec, but they have compared two different implementations. One is the X265, I think, and the other one is LibAV codec. So it is to take into consideration because lots of people might go and use those software or those solutions, but it's probably not definitive. By all means, both VP9 and HEVC have an edge over H.264, and they can deliver it. The ambition is by end of this year or first quarter of next year, AV1 to come out in the market and try to achieve the promised 50% additional on top of those two. That will be probably the icebreaker that will make everyone capable of broadcasting HEVC. Oh, go ahead, please.
I have a very naive question. People talk about all these comparisons. The question is always with respect to what metric?
Sorry, can you say it again, please?
Oh, okay.
The Netflix, I read the article, they use both PSNR, SSIM, their own metric, and they kind of combine the whole thing. Netflix have released their own, what they call it, VQMT thing. VMAF, okay. Okay, yeah, they use their own metric, but they also relied on PSNR and SSIM metrics. They need to have a benchmarking mechanism, so we can argue about which metric is good or not. I personally do agree on using metrics plus some visual tests like most tests. It all builds together. We need to have a mechanism that all of us agree on, otherwise we'll never be able to say this is better than the other one, right? Okay, I'll carry on. So in terms of compression, H.264, really some experimentation I've done myself. To achieve a good quality and deliver Ultra HD, you'll not go on reasonable medium motion content. You're not going to go below 40 megabits per second. And that's not something we can consider today. On top of the codec itself, there is the delivery mechanism or the packaging mechanism. Today, the main two-way BR mechanism are HLS and Dash. And there might be others as we go because the Alliance of Open Media is thinking to develop their own. HLS, iOS devices, I'm not sure there are iOS devices today capable of 4K display. So probably someone might think, okay, 4K is mainly for big screens. And actually, some of you have attended the keynotes where the presenter was talking about 80% of the content, 80% more content is displayed on TVs. That is good news for people who want really to go and broadcast their 4K content because they know it's for TV and there are lots of 4K TVs, which is the main 4K screen available today. So for example, I'm not aware of any mobile device that can do 4K, and probably it's not worth it. From experience point of view, to watch a good 4K and enjoy the experience, you need to be at specific distance from the screen, and the screen must be more than 40 inch. So it's really shifting a little bit the direction of the market of the business you'd like to drive your streaming to, and for your customers as well. Dash is there, and besides, HLS does only today support H.264, does not support HEVC or VP9, although it's not a big deal. I know our colleagues at Amazon, from Elemental specifically, they've done an experimentation where they replaced the H.264 stream with an HEVC stream, and they have done the A to Z kind of end-to-end test, and it did work fine. For VOD, the transcoding is simple. That's why we have seen in the market VOD applications and VOD streams coming first. You see, Netflix, they started it. And there are lots of other players. Amazon are doing 4K as well. For VOD, it's easier because you can transcode many times. You can do it offline. In addition, most VOD content is movies, and it is 24 frames per second. For live, the story is slightly different, and especially for those who would like to broadcast sports and things. They need to use encoders who are real-time encoders, which will be less efficient than non-real-time encoders. They have to do it only once. There is not much for them to enjoy, really. And that's why the bitrate range between the VOD application and the live application are slightly different. This is from the compression point of view. I got this picture from Akamai. This is describing the bitrates per country, the progress of bandwidth of average connections over countries. And as you can see from that, over the last 5 years, we've seen a move from an average of 10 megabits per second to probably 15 to 20 megabits per second, except if you probably look at Hong Kong as an exception here. If you try the other countries, I have the link here, which will go to the application. You can put any country you want in the world, and it will give you the stream. With those bit rates, we're not going to be able really to watch a good experience of Ultra HD, very good quality. Please go ahead, sir.
And it's even worse on that, right? Because if you look at the average according to our analysis of the bandwidth in the US, and what actually Netflix can deliver, which is up to fiber optic.
Correct. Agreed.
There's a big gap because of all the fighting with the internet distributions and penalizing kind of.
If I got your point correct, so you're saying there is difference between what we call average here and some peaks and some regions. Is that correct?
So there's a difference between what your bandwidth and what you can effectively get from streaming content because they get penalized.
Oh, okay, I see your point. So basically, yeah, some providers will cap the limit per provider. Like I know Comcast for a fact, they cap how much Netflix can go through. That's absolutely right. But I think that's still debatable, and there is legislation coming into effect in the US. I'm not from the US, but I've heard about some talks about legislation to allow people to, media providers. Media will be like 80%, as was told on the keynote today in 2020. So having caps will really hurt the business. I think there will be more discussions, and the bandwidth will just go higher. Actually, you brought a good point as well, because I showed you the averages, and here the average sometimes gets you confused, because really 4K is still almost a niche market, right? So if you have the average of 10, but you still have 30% of your people, they have 20 or 25 megabits per second, that's still good for you. This is, again, from Akamai. I love their data. As you can see, there are 3 cases here which I would like to show you guys. 30% of people connected globally have got above 10 megabits per second. 19% only have got above 15 megabits per second, and only 7.1% globally have got more than 25 megabits per second, which is the ideal for life. So it's still a small market, but it really depends on from one region to another. I looked at the US. I think it's much higher than that for people who would like to launch some businesses here. But the market is moving a bit slower, but it's going to be there to enable you to send your Ultra HD with today's codecs as well. So on the encoding bitrates, I think I did talk about this at some point. Really, when you come to decide on your ABR, including Ultra HD, you need to decide what is the bitrate versus what is the bandwidth of my customers. And that is the painful challenge. You can say the bandwidth is a decider, because ultimately sending something that no one can watch is pretty much useless. So really, people need to invest on a good codecs, not using whatever is available free of charge. It could be a software-based codec for easier replacement when eventually AV1 will come to the market. But these are something that people need to look at. Here I mentioned for live, for 60 frames per second, 25 to 30 is what people use. BT in UK uses slightly more than 25 megabits per second, and the experience is having lots of success. However, they're not sending OTT, they're sending IPTV. So it's not really on the public internet, it's fairly driven by service providers helping to deliver that content. I guess if they go OTT, they will start having problems. For VOD, we know, all of us, that Netflix has got some content, Amazon has got content, and lots of VOD players start having content out there, and it's being delivered. Well, this is a big question. How do you know you're watching 4K, really? Because some people will allow you to view that little window that YouTube shows you or Twitch shows you, which you can say, OK, I'm watching the 4K version right now, and it's great. But since everyone transcodes the input in multiple resolutions, so you can have a 4K rendition as 15 megabits per second. Underneath it will be the 1440 at 10 megabits per second, then the 1080p at eventually 6 megabits per second. So what you'll be watching is something you don't really know, whether your bandwidth is allowing you to watching your 4K experience. And you might think, because the content is 4K, oh, I'm enjoying the great experience. And that's kind of reasonable to hide it, but it's not the fault of the provider themselves. It's kind of a compromise people need to do, hiding the statistics eventually from the customers eventually. I'm not recommending this, but it is one way to say, yes, this is 4K content for the customer. Transcoding is one. The delivery chain or the bandwidth or the pipe is one. And now here is some data I got from the internet, actually, talking about how you can play it back. Because, OK, I can deliver HEVC. Imagine I have the greatest HEVC or VP9 encoder, which could generate a great quality at low bit rates, and it's going to go to the customer. How is he going to watch it? He needs to have the decoding capability and playback capability. In terms of the HEVC and VP9, who are the 2 contestants right now to delivering Ultra HD content, these are the list of, if you look at the web browsers, these are the browsers which support one or the other. From the TV point of view, the TV is still having this culture, I could be wrong, but the TV is still having this culture of the broadcast is a big drive anyway for the TV, and it looks like the broadcast is going for an HEVC codec. So most of the new TVs, they have got an HEVC built-in decoder, more than VP9. Although, you know, like the presentation this morning again, Roku is really kind of trying to work into the TV business, which brings the TV into the OTT market, where VP9 could be a contestant as well. But there are few, but not as much as HEVC. I've been at IBC this year, and the HEVC is everywhere, in set-top boxes, in small internet boxes, but VP9 is pretty much not very well present. It's mainly driven by Google, and I haven't myself watched any stream VP9 except coming from Google. This is my last slide, and here is why I kind of brainstorm a little bit with myself and you guys, just to think, okay, I'm a businessman who wants to launch my own 4K content. So first of all, I study my bandwidth. I study my customers. I make sure my content comes great. But I also make sure what are the bit rates that really suit my content. We at Twitch, our content is gaming. Gaming is super challenging in terms of we need to keep the 10-bit, the 60 frames per second. But also, it's not a camera-generated content. It's a content that could be random, that could have lots of artifacts, which will even make it a harder job for the encoder to generate a good bit stream at lower bit rate. So what I'm thinking, okay, I'm going to dedicate what I call stack for my Ultra HD delivery and the stack for my traditional. Because you should not forget that this is a transition rather than just a black and white. You have content today that is generated in 4K. You want to deliver the same content for people who have small devices today, who have all technology, what we call today all technology, still the H.264, which 90% or 99% of the market still use, and still to make them satisfied by giving them a slack. So still encode everything on H.264. To start your Ultra HD content, you need to start a completely different slack, transcode everything in HEVC, because you cannot find a device that can, for the 4K and probably something above, and 1440, will decode HEVC. As soon as your bandwidth goes low and you move to 1080p, to move to an H.264 decoders. That's not very well defined and available right now in the market. So switching codecs on a live event does not happen. Although it's something that people are working on, doesn't exist right now. And also try to make sure your bitrate goes great. Do not deliver Ultra HD if you're going to deliver a bad quality. There is no point. Probably go 1440p. You can encode it, but encode at a high bitrate. Don't worry about whether your customer is going to see it today or not. Some might. In the future, they will. But do not go your Ultra HD content, encode it at 15 megabits per second for live, make it look rubbish, make it 1080p, make 1080p look even better than it, and then you lose your customers. Because Ultra HD and what we call the high bitrate video is about the experience. And that brings the end of my presentation. Short and nice. Thanks very much. If there is no question, we can all go for lunch.
I don't know if you're related, but you know, Google signed up a bunch of major TV companies to start using the Android TV OS.
Okay.
Do you have that's in any way that may improve the chances of penetration of
VP9. I remember at CES 2015, I'm not aware of that exact deal or the try. I know Google are pushing very hard to get VP9 to be adopted on TV sets and other equipments. I remember at CES there was lots of promises from LG, for example. They said they will support in all the 4K TVs they bring into the market VP9, but that did never happen. More than that, Samsung, I think, released at some point a press release saying, yes, they will work on adding VP9. I think the reason is the earlier studies of quality evaluation of VP9 came to show VP9 lesser than HEVC by more than 20%. Things have moved from that point of view. The codec has been developing even further, and there is a VP10 coming. And actually, AV1, which is the AOM codec right now, is built based on VP9. And it is an enhancement being added to VP9. In addition to that, there is the DALA codecs and the Mozilla codec as well. Cisco, sorry. Cisco DALA and yes, correct. Cisco Phone and Mozilla DALA. It's not known. It looks like the VP9 is still a Google 90% or 99% usage. It's a great codec. Hopefully, the AV1 will be the replacement of both VP9 and HEVC if it brings the promised 50% compression efficiency. AV1 is the Alliance of Open Media. It's a group of open Sir, yeah.
I guess even with the stated goals of AP1's compression gains, would that solve the connectivity challenge in terms of getting to the data rates? So you have more homes that can receive UHD? Or you need to
Well,
still see this need to solve both problems?
I think both are going to happen anyway. So increasing the connectivity of customers and improving the bandwidth is definitely going to happen. You see that is the trend already, regardless of whether you send Ultra HD or not. But however, imagine the 50% AV1 is promising will be delivered. That means we can encode a good quality a good quality Ultra HD content at probably 12 megabits per second, which will be watchable at least at those sort of bandwidths. Okay, thank you very much.